So I just wanted to make this quick video just about a little project that I was working on during the week. Made this PCB board here. Just drew the circuit, etched it out, and it's basically a circuit for testing your output transistors. So an output transistor has a curve that it follows for the current and for the VCE, and you find it in your transistor specification sheets. And yeah, it's called a safe operating area curve, and I'll just find it here. There it is here. So this is it here, active region safe operating area. So as you can see here, this here is your VCE, that's the voltage between your collector and your emitter, and this is the voltage here, so it's a logarithmic scale, so 1 volt, 2 up to 10, then 20, 30, whatever, up to 100. So, and then this is the current going through here, 1 amp up to 10 amps. So if our VCE, for example, would be 30, we could safely operate this device up to, say, I can't see that exactly, but probably about 8 amps or 7 or 8 amps. So what I wanted to do was make a device that I can basically test that and use an input signal here. I'm just not too sure if it's going to focus. There we are. Is basically a reference voltage. So if I basically turn this to, say, let's just move the parameter over here. If I change this to 1 volt, I wanted the 1 volt to equal 1 amp. So you can see on this dial here you got 1 amp, and then over here on the right hand side you got 12.6. so that's my VCE, that's the voltage between my collector and my emitter. So I can, if I now dial this up to 2, I'll now get basically 2 amps between my, then I have to just close the blind here a little bit, about 2 amps, and my VCE is dropped to 9.71. So close the blind here a little bit. So yeah, so it's quite accurate. It uses a it's just underneath here. It uses I sort of made the board a little bit incorrectly, so I had to solder this op amp in upside down, but it basically uses an op amp and then as a comparator to compare the voltage at the emitter, and that way it's like a negative feedback, and it creates that and uses that negative feedback to generate this amperage. Now this is my load resistor here. It's basically two 4 ohm brake resistors in parallel to get me down to about 2 ohms, and they're about 1000 watt each, but so I don't have to worry about anything getting hot. Output transistor here is on this heatsink. It's probably not really big enough, but it's only slightly warm, it's no big deal. So yeah, I can control this quite accurately, surprisingly. Even if I drop this to, say, 500, I'll show you here, it's now on 0.5 of a volt, so I should get about 500 milliamps through the transistor. So yeah, so that's my circuit. I've got the other side here. This is for the PNP side. I just need to populate these other components, and there are other resistors here. The PNP reference voltage will be here, so I just need to drop that in. This here is just used because, you know, your resistor is probably not exactly perfect when you first set it up, so this here you just use this calibration just for your output voltage. So when you're dialed up on here at 1 volt, So let me just get this out there again. So yeah, so when that's reading, just trying to see, it's not focusing real well on the backlit screen there. Might just have to take my word for it, but there we are. So when that's saying 1 volt on there, you adjust this pot here, and I just put an ammeter initially where my load is. This is where the load's connected. So this is the load. So the load's connected in here. So I just use an ammeter initially to use this pot to adjust that to be spot on 1 amp. And then when that was done, I then set up this other pot here, took the voltmeter off, the ammeter off, and then I'll use this pot here and adjust this till this reads 1 amp. Well, it's basically 1 volt, but because of the voltage divider network that I've set up here, it's equivalent to 1 amp. It's basically, it's just like using a voltmeter to read amps. So yeah, it's not too bad. And yeah, so I set all that up, and I'm able to test these output transistors now and run them up to check this safe operating region, and just test the output transistor meets specifications without blowing up, because some of the transistors that you do buy on eBay are a bit dodgy. So yeah, you might want to check them and that sort of stuff. So that's why I made the device, just to check some of these output transistors. And yeah, so I hope that was interesting, and yeah, leave comments below if you like.